Algebra 1 final review. We'll start with Chapter 8. Chapter 8 was all about exponents. If we look at number 1, we have x to the 7th times x squared times x to the 5th. When we're multiplying, we want to remember that we need to keep the base the same, but add the exponents. So 7 plus 2 plus 5 would be 14, so our final answer is x to the 14th. For number 2, we have z to the 5th y cubed times negative 2 z to the 4th y to the 8th. So again, we're multiplying, so we want to remember to add our exponents. We don't have anyone to multiply this negative 2 with, so we'll just leave him as negative 2. We have a z to the 5th and a z to the 4th, so when we add our exponents, he'll become z to the 9th. And we have y to the 3rd and y to the 8th, and when we add those exponents, that will become y to the 11th. For number 3, we have a to the 4th raised to the 3rd. So we have a power being raised to another power. In this situation, we want to multiply the exponents. So our final answer will be a to the 12th. For number 4, we have 2x cubed z, all raised to the 4th, times 3x to the 9th z squared. What we want to do for this one is raise everybody in the first term to the 4th power. And remember to distribute the 4 to everyone in that parenthesis. So we're going to end up with 2 to the 4th. And remember, we want to multiply our exponents. So this will become x to the 12th, z to the 4th. And that is still times 3x to the 9th, z squared. To figure out what 2 to the 4th is, we need to multiply 2 by itself 4 times. So 2 times 2 is 4, times 2 again is 8, times 2 one more time is 16. So we have 16 x to the 12th, z to the 4th, times 3 x to the 9th, z squared. So now we can multiply our numbers together. So 16 times 3 is 48. X to the 12th times x to the 9th, we want to add our exponents, so that will be x to the 21st. And z to the 4th times z squared, we want to add our exponents, so that will be z to the 6th. For number 5, we have 4 to the 4th raised to the 4th. Don't let all the 4s confuse you. This is just a power being raised to another power. So we want to remember to multiply our exponents. 4 times 4 is 16, so this gives us 4 to the 16th power. This is all you'll need to do for this problem since this is a non-calculator final. For number 6, we have negative 2 over b raised to the 4th. So for this, we want to remember to distribute the 4 to both the numerator and the denominator. So that will give us negative 2 to the 4th all over b to the 4th. And we want to put negative 2 in parentheses because we're multiplying negative 2 by itself 4 times. So negative 2 times negative 2 is a positive 4. Positive 4 times negative 2 is a negative 8. Negative 8 times negative 2 is a positive 16 over b to the 4th. For number 7, we have 3 to the 7th over 3 to the 3rd. We want to remember that when we're dividing, we subtract our exponents. So 7 minus 3 is 4, so our final answer is 3 to the 4th. For number 8, we have 7 squared times 7 to the 9th. We want to remember that when we're multiplying, we add our exponents and our base remains the same. So our final answer is 7 to the 11th. Number 9 works the same way. We're multiplying, so we want to add our exponents. So the answer is 2 to the 3rd. And number 10, again, we're adding, so x to the 10th. Moving on down to our last few problems. For number 11, we have 3 squared times 2 times 8 to the 0 power. So we know that 3 squared is 9. We don't need to do anything with the 2. But we should remember that anything raised to the 0 power equals 1. So 8 to the 0 power is 1. So now all we need to do is multiply 9 times 2 times 1, which is 18. For number 12, we have 5 to the 0 times 5 to the negative 7. 5 to the 0 is 1, and we still have 5 to the negative 7th. 1 times 5 to the negative 7th is just 5 to the negative 7th. But we also want to remember what we do with negative exponents. If we are raising anything to a negative exponent, we want to move him to the denominator of a fraction, and the exponent will become positive. So we have 1 over 5 to the 7th. For 13, we have x to the 4th divided by y to the 9th raised to the 3rd. So we want to distribute our exponent to both the numerator and the denominator. And we need to remember that we need to multiply our exponents. So we have x to the 12th over y to the 27th. And you need to stop at this point. We are not allowed to subtract our exponents in this case because the bases are different. We have an x and a y. So that is our final answer. For scientific notation, we need to make whatever number we have a number that is in between 1 and 10. So if we have 0.000000852, we need to move the decimal point over 1, 2, 3, 4, 5, 6 places. So that gives us 8.52 times, we always use a 10, and since we made a number bigger, instead of raising it to a positive 6, we're going to raise it to a negative 6. If you multiply this back out, raising something to the negative 6 would make it smaller because it would make it a fraction. For number 15, we want to write 3,456 in scientific notation. So we want to imagine that there's a decimal point that we can't see in the back of this number. So again, we need to make this number in between 1 and 10. So we're going to move the decimal point over 1, 2, 3 times to give us 3.456 times 10. And since we moved the decimal place over 3 times 10 to the 3rd.